Hello, everyone. A very good morning to all of you, dear authors, and all the invited guests. A very warm welcome to the technical session 1C. So, myself, Yashita, and I'll be moderating you for this session. I'll be making sure everything runs smoothly. Uh, and on behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communication Technology for Intelligent Systems, which is ICTIS 2026. So, the 11th edition of the conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, Thailand, while the virtual sessions are being conducted via Zoom from 9th to 11th April 2026, where people from all over India as well as many from other countries are present with us. So I hope you all enjoy today's insightful, knowledgeable, and interactive sessions. So in this session, we will be having 10 presentations. Each presenter will be given 10 minutes for presentation, followed by 2 to 3 minutes for the question and answers. And I will be giving gentle reminders at 9-minute mark just to help everyone stay on track. So, also a small request to all the participants, please stay connected with us till the closing remarks. We promise that it will be worth it. And if you have any queries or updates, feel free to drop them in the chat box anytime. Okay, so before we begin, I would like to introduce to our session chair. We have with us Dr. Shri Kumar Nayak, who is a principal engineer at Insedo INC, United States, and a seasoned AI leader with 15 plus years of experience in building and scaling enterprise AI and generative AI LLMs platforms. He specializes in fraud detection, financial crime solutions, and cloud native architectures across AWS, Azure, and GCP. So, Shri Kumar sir, would you like to give some welcome remarks?
Yeah, thanks, Yashika,
Yeah.
for the introduction. Okay, so so I just logged in. Yeah, you are able to see me, right? I
Yeah,
just
yeah.
dialed in. Okay. Okay, so thanks for that. Thanks for the opportunity for chairing this session. I hope we'll have a great interaction across all the technologies and the challenges, the assumption, the methodologies. So I would welcome everyone to to come up with to take this opportunity for meaningful discussions and so that we can explore more cutting edge research as well as the all the things that you guys can share your insights, participate. I would encourage to ask a lot of questions when you have the opportunity to do that. So welcome everyone to this conference. And I think Ashika, this has been held in two locations, right? So one in
Ye-
Bangkok and another is in New York.
Yes, no,
Um,
in Thailand, Bangkok, and in Thailand, and then uh, uh, the online is
okay.
from 9th to 11th. Yeah.
Oh yeah, so we do have in two location. Thanks
Yeah.
for that. Thank you.
Yeah.
Okay, welcome everyone. And so this is for 10 minutes, right? So we have 10 minutes for each session and two
Each
minutes.
presentation, yes, we have
Yeah,
2 to 3 minutes of question answers. You can ask your questions to the presenters.
thank you. Thank you. Thank
Yeah, yeah. So let's begin with the. Oh, wait, I'll admit some people. Yeah. Now let's begin with the presentations. So our first presentation we have uh, a paper titled "A Boundary-Driven Lightweight Segmentation Framework for Robust Image Enhancement in CCTV Surveillance," which is being presented by Jeba Priya. Are you there in the meeting? I think no. So let's move on to the next presenter. I think she's also not there in the meeting. Okay, so we have the paper titled as Analyzing Socio-Environmental Determinants of Teen Suicide in US Counties Using K-mean Clustering Based Machine Learning Approach. So, Vishnu Kumar sir, are you there in the meeting?
Yes, I am here.
Yes,
Can
you're
you hear
ready
me?
with the presentation?
Yes, I can. I can start.
Yes, yes, then you can start. Wait, I'll stop sharing my screen. Yes, okay. You can start. Just a reminder, you have 9 minutes with you. Wrap up in those 9 minutes so that the session will stay on the track.
Sure. Okay.
Yeah.
Hopefully, you can see my screen.
Yes, yes. That is visible.
So, hello everybody. My name is Vishnu Kumar. I, along with my co-author Ariana Kopp, we are here presenting our paper titled "Analyzing Socio-Environmental Determinants of Teen Suicides in U.S. Counties Using K-Means Clustering-Based Machine Learning Approach." So, I'll first start with the introduction. So, as some of you might already know, see, teen suicide has becoming a big issue in the U.S. and across the globe. So, the statistics shows that there's a growing rate of suicides across the US counties in the last 10 years have shown this figure here. So in 1999, it was about 10.40 per 10,000 suicide rates, but then it has significantly grown in the last 20 years to 14.47. So that's kind of a alarming growth in the suicide rates. Now, if you particularly look into the teen suicides, the statistics shows that among the total teen deaths, suicide is one among the top most factor that causes death among teenagers. So, as you can see in this picture here, suicide ranks as the number two leading cause of death among teenagers. So, with this being said, it's kind of clearly evident that suicide is really a big challenge in teenagers in the United States. Now, people have been studying suicides for quite some time. People have been doing machine learning based studies, traditional approaches in the past. People have been also looking into teen suicides. But then people have found that the county level studies, especially the county level studies, has shown substantial variation um, in teen suicide risk across the regions. So there are some areas, such as the ones shown in the picture here in dark color, that have high suicide rates, whereas there are some regions that have significantly low suicide rates. So the distribution is kind of uneven across the country, that's in the US, and the picture kind of depicts that pattern here. Now, the previous studies have also shown that the rural and socioeconomically disadvantaged area experience high suicide rates. Now, people have also found that the geographical patterns suggest that suicide risk is not just based on some individual level phenomena, but are driven by various contextual and socioeconomic factors. And these include factors such as access to healthcare services, economic stability, community level supports, and other issues such as poverty, unemployment, etc., in a particular geographical location. Now, although people have been studying suicides in the past, there has been a lot of gaps in the existing research. So most of the work in the past have been examining risk factors in isolation, means that they just analyze one risk factor, maybe poverty and suicides, or maybe they just look into access to healthcare and suicide. And the work often ignores the interplay of multiple risk factors. Now, most of the work in the past have just looked into some simple statistical models, and research has shown that they don't actually capture the nonlinear interactions among the different variables that can affect the suicide rates. Now, again, people focus at a larger geographical area, such as maybe at the state level or maybe at a national level, and often generalize the result. But then from the picture that I showed in the previous slide shows that there has been some geographical variations. And it is important for us to get down into at least a small geographical zone, such as a county, to get a better idea of what is happening with respect to the factors that affect the suicide rates. Now, the main objective of our study it starts from collecting data on various socioeconomic factors at the county level for all the US counties. And then we are trying to develop a K-means clustering model. Now, the goal is to identify county level groups that can share similar multidimensional risk profiles. Now, the overall objective is to provide a more nuanced insights on how different combination of contextual factors relate to teen suicide risk across the different US counties. So now I'll move quickly to the methodology. So the first is the data description. So the figure here shows the different contextual factors that we used in our analysis. Now, all of these factors were based on publicly available data sets, which means it can be freely accessible by anybody. Now, we looked at the data from 2019 to 2023, and we just looked into 248 counties that reported teen suicide counts. And this work includes 11 county-level features along with the data source from which they were obtained. Now, moving over to the k-means clustering algorithm. So first, we did some pre-processing steps, making sure that the data is clean. We handled some missing values, and we also standardized the data set. And the first step in the k-means clustering algorithm was to identify the optimal number of clusters, which is actually the k values. So for this step, we use the Szilard scores as shown in the figure here. And then the optimal value based on the Szilard score shows that k equal to 2 is the optimal number of clusters. And that's what we used in our methodology. Now, all the implementation was done using Python. Now, if we move to the results and discussions. So after running the k-means clustering algorithm, we found based on using two clusters, we kind of see the two clusters shown in this figure here. So we see that the cluster 0 corresponds to the low teen risk cluster, whereas the cluster 1 shows the high teen risk cluster. And then the numbers actually reflect on why we made the high risk cluster and the low risk clusters. Now, we also looked into the different county level features. So we see that for the low risk clusters, the hospitalization rate, the mental health provider rates, and the primary health provider rate and the association rate is much higher than the high risk cluster. Whereas for the high risk clusters, we have people who are more poor, there are more uninsured people, and then there's more insecurity and more rural residents in the high risk clusters. So this kind of an observation that we can obtain from our analysis. Now, we also wanted to see if there's any significant difference between the two clusters for which we used ANOVA p-values. So we see that among the two clusters, there is a significant difference between the cluster 0 and cluster 1 for most of the features, except for the teen suicide hospitalization rate. Now, we also wanted to see if the model was able to capture the clusters. And then we see that based on our principal component analysis, we see that the two clusters are distinctively captured by our model. Now, moving over to the discussions. So we see that the cluster 0 corresponded to the low risk cluster. So in the low risk cluster, we found that it had low levels of poverty and low food insecurity, which means that the people in that particular region have more economic stability and more access to mental health resources and other healthcare facilities. Now, we also observed that within the low risk cluster, there were less rural residents, meaning that more people had access to much of the urban facilities like healthcare facilities, more educational services, and other community resources that can help us prevent the teen suicides. Now, when you look at the high-risk clusters, most of the high-risk clusters had high poverty rate, which means that there were increased stress among the people. There were reduced access to mental health services among the poor people in that counties, which might have led to increased suicide rates. Now, these high-risk counties also had higher food insecurity, which means that they have more broader economic challenges, housing instability that can be linked to poor mental health outcomes. Now, again, most of these people in the high-risk counties were uninsured, which means that, again, they have less access to preventive and mental health care. Now, one of the features that showed no difference between the two clusters was the hospitalization rate, which may be due to the fact that hospitalization rate, the data actually might reflect access to acute healthcare. So people might use hospitals just for maybe flu or fever, so that may not actually be related to suicide. So that might be the reason why there is no difference, significant difference for the hospitalization factor among the two clusters. Now, what is the implication of this work? So one of the main implications is that we found the two clusters, the high risk cluster and the low risk cluster. So in the by identifying the factors that are leading to more teen suicide in the high risk cluster and the factors that are controlling the teen suicide risk in the low clusters might help the policymakers prioritize the high risk clusters and also learn from the low risk clusters on how they are managing. And that can be kind of a path forward for controlling suicides in the high risk clusters. Now, our work did have a few study limitations. So again, we looked for the counties that reported some teen suicide values, and we ignored those with zero and unreported values. So that might have had some effect on the clusters, on the patterns. Now, finally, most of we in our work we just looked at 11 socioeconomic features. So there might be some other features which we might have ignored that could have affected the teen suicide rate. But overall, our project shows that machine learning, that is specifically the clustering, k-means clustering, might give us some insights on why some counties have high suicide risk as opposed to some other counties which have low suicide risk. So with that being said, I would like to conclude, and thank you so much for your attention, and I'm open to any questions that you might have. Thank you.
Okay, so before moving towards the question and answer session, I would like to introduce you all to our second session chair, Dr. Nitin Dhawas, sir. Welcome, sir. Hello. Uh, am I audible, sir? Your voice is not audible. Okay, I think there is some issue with his voice. So, can you stop sharing the screen, Vishnu, sir? Yeah, okay. So I'll quickly introduce Nitin sir till his issue is getting solved. So Dr. Nitin Dhawal sir is a professor and dean academics at Nutan Maharashtra Institute of Engineering and Technology, Pune. So his research areas include engineering education, academic administration, and emerging technologies in computer science. He is actively involved in teaching, academic leadership, curriculum development, and institutional growth in technical education. So, is the problem solved, sir? No, not yet, I think. Okay. So, okay, so Shri Kumar, sir, you can move forward with your questions. I will
Yeah, I
figure
have a
out.
quick question, Vishnu, on your paper. So why did you
Yes.
select the K-mean clusterings for identifying the country level suicide risk profile? I mean, how might the results would have differ if you would have selected some different unsupervised or supervised machine learning technique? What would have been the difference as
So
compared to the K-means? Yeah.
I guess most the reason why we picked the k-means was to identify the clusters and identifying which features actually influence those clusters. So we wanted to go for unsupervised because we didn't want to guide the models to make us particular decisions that we want. So unsupervised means it just create looks at the patterns and makes its own decisions without any predetermined labels or anything. So we wanted to see how the model would perform and what are the factors within each clusters that might give us some information. Now, I have seen people in the past using supervised machine learning, like they do some regressions or decision trees. So essentially, they are trying to predict suicide rates. So our goal was not to predict suicide rates, but instead we want to see what are the factors that lead to high risk counties and low risk counties. So that being said, we thought k-means might be a great tool.
Okay. Thank you, Vishnu. Thanks. We almost done. Thanks for the answer. Bye.
Thank you.
Yeah. Yeah, Shika. Ishita. Yeah.
Yes. So, Nitin sir, can you try to rejoin the session? So, the issue will be solved. No, you're not audible till now. Okay, so for now, let's let's move on with the next presenter. So next we have Adi Shri Praveen Pai with her research work titled as Code Forge, a three-tier hybrid framework for automated Python code optimization. So are you there, Praveen?
Hello, am I audible?
Yes. So
Okay.
are you ready with the presentation?
Yes, and my name is Adishri, not
Okay,
Praveen.
Adi, sorry.
Yeah, it's okay.
Yeah, so you can share your screen. I'll stop sharing.
Hello.
Yeah, are you sharing the screen?
Yes, I'm trying right now.
Yeah.
Ishita, we need to move on. because we have a lot of. Can't
Yes,
hear
good
you.
morning, Yashita.
Yes, sir. Finally, you're audible.
Am I audible now, ma'am?
Yes, 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 you're audible,
Yes,
sir.
thank you, ma'am.
Yes, welcome. So, Adishri, we are moving to the next presentation. Resolve the issue and we will take your presentation later. So, next we have with us Rahul Singh to present his paper titled as Performance Analysis of Brain Tumor Classification Using Computer Vision Based Transformer and Swin Transformer Techniques. So, Rahul, are you there in the meeting?
Yes, yes. Am I
Yes,
audible?
yes. You can start sharing your screen.
Is screen visible?
Yes, it is visible. You can start.
So, good morning, everyone. I am Rahul Singh from JNU New Delhi. I am here to present my work titled as Performance Analysis of Brain Tumor Classification using Vision Transformer and Swin Transformer Techniques at ICTIS 2026. This is the outline of my presentation. I will begin with the introduction and literature review, followed by the methodology and experimental setup. Then I will discuss the results, convergence analysis, and statistical validation, and finally conclude with future direction. So brain tumors are a life-threatening disease where early detection is crucial. MRI is widely used for diagnosis, but manual analysis by radiologists is time-consuming and prone to human error. This creates a need for automated and accurate classification system. The main objective of our study uh, is to perform comparative analysis between vision transformer and swin transformer for brain tumor classification. We will evaluate multiple aspects including computational efficiency, convergence behavior, and model stability. We also analyze class-wise performance using confusion matrices and validate our result using statistical significance testing through McNemar's test. Okay, so this table summarizes key existing approaches. So the first one is CNN-based models. These models shown strong performances in medical imaging, but they are limited in capturing global context due to local receptive fields. Vision Transformer introduced self-attention mechanism, allowing global relationships between image patches to be modeled. However, it has a high computational cost. Swin Transformer improves upon this by using window-based attention and hierarchical representation, making it more efficient and scalable. CNN mainly focus on local features and lack global context. Transformers overcome this by modeling long-range dependencies using attention mechanism. With the help of transformer, we can get global features and
बोलो सर, आ गए आ गए। नहीं नहीं, इधर एक मेरा सेशन चेयर है, वो करके आता हूँ।
Nitin sir, I request you to please mute your mic.
वेट वेट।
Yeah.
should I continue?
यस यस।
Yes.
Uh, so we use the BRICS 2025 dataset, which contain 6,000 MRI images divided into four classes, namely glioma, meningioma, pituitary, and non-tumor. Uh, the data set provide predefined train and test split to ensure fair evaluation. At first, all images were resized into 224 by 224 pixel and normalized using ImageNet statistics. As our both models were pre-trained on ImageNet dataset, that's why we have to perform normalization using ImageNet statistics. We applied horizontal flipping during training to improve generalization. Here is Vision Transformer architecture. VIT divides images into patches and processes them as tokens using self-attention. It captures global dependencies but has high computational cost. Swing Transformer uses window-based attention and shifted windows to enable cross-window attention. It is more efficient and scalable compared to VIT. Here is the experiment setup and training configuration. Both models were trained under identical condition using Adam W optimizer. Learning rate was set to 0.00001 and batch size of 16 is used. This ensures a fair comparison between the models. Here is the confusion matrix of swing transformer. Here we can see most prediction lie along the diagonal, indicating high accuracy. Very few misclassification are observed, and models performs consistently across all classes. We can see some misclassification in glioma and meningioma. That is because of their similar structure, and but they are minimal. Uh, this is the training and loss curve for vision transformer. Here we can see fluctuation in validation accuracy and loss. This indicates instability and possible overfitting. And here is the training and loss curve of swing transformer. Uh, on contrast to vision transformer, this shows smooth convergence behavior. We can see minimal gap between training and validation curves. It shows better stability. Uh, to make sure that our model is not actually insignificant, we use McNamara test to compare both models. The p-value we got is 0.2266, which is greater than value of 0.05, which shows that the performance is not statistically significant. Both models achieve very high accuracy with the VIT at 99.17% and Swin transformer at 99.27%. The difference between both models is quite minimal. Both models achieve identical class-wise performance with precision recall and F1 score close to 1 across all tumor categories. And here are the key findings. Both models achieve similar accuracy, although Swin transformer is more efficient and requiring fewer parameters and less computational power. VIT has small fluctuation in validation accuracy, which might imply overfitting in the model. And here's the conclusion. A transformer-based model are highly effective for brain tumor classification, while both models perform similarly. Swin transformer provide better efficiency, making it more suitable for real-world deployment. Uh, in future work, we plan to evaluate this model on a more diverse dataset and try to combine CNN plus transformer to make a hybrid model. We will try to optimize model for real-time clinical deployment. and we will evaluate performance on multimodal data. Thank you.
Do you have any questions for him?
Yes. Do you have any questions?
No, I just want to know what are the limitations of transforming this ImageNet weights to the medical imaging domains. I don't see any limitations of this, but yeah, if you can highlight, that's all.
Sir, we actually pre-trained our models on ImageNet dataset because we do not have a large dataset for that, and
Mm-hmm.
that's why we have to perform a normalization using ImageNet.
Mm-hmm.
Yes,
You
sir.
don't have any limitations when you're transferring this pre-trained weights to medical imaging domains?
No, sir.
Okay, thank you.
Good morning, Rahul.
Good morning, sir.
Yeah, what are the potential challenges you faced during your research?
Actually, sir, when I was studying the first, this was actually my first conference, and I have to study all the models deeply and understand them. Yes, sir.
Okay,
And yes.
okay, okay. How can this research be applied in industry, or what are the applications where we can use?
Uh, sir, this is sir, this research can be used for classification for automated brain tumor classification.
Okay,
Yes, sir.
okay. Thank you so much, Rahul.
Thank you, sir.
Can I present next?
Yes, yes, yes. I was going to ask the same. Adishri,
Okay.
you can present. Yeah.
Okay, thank you.
Just wrap it up in like 8 to 9 minutes. The presentation should be very crisp on the point, okay? Because we should not lose any sort of time and lose track for all the sessions today. Can you quickly share your screen, Adishri?
Is it visible?
Yes, it is visible. You can start.
Okay, thank you. Good morning to one and all here. I'm here to present my project Codeforge, and it's basically a hybrid AI powered code optimization framework. So, we know that there are already other LLM based tools, but they just simply rewrite code and then assume it's faster. So, what my project does is it validates the performance using a production grade benchmarking pipeline. So we have combined compiler inspired rules here. Then there's semantic pattern detection and statistical outlier rejection and a complete mathematical confidence scoring system. So we make sure that every optimization is benchmarked using warm-up runs, median-based timing, IQR filtering, and variance analysis. So we are not just rewriting code here, we are making sure that there are safe, measurable, and explainable performance improvements. So, as I said, it's basically an AI powered Python code optimization pipeline, and it transforms any unoptimized code into faster version. We have three tiers here, and it's all sequential. There's an AST rule analysis, semantic similarity search, and a Gemini LLM rewriting. And this is all combined into one fast API service. So, what is the problem statement here? It's so we know that all of us developers we struggle to, you know, write code. It's like a tedious process, and we don't get feedback. Then the second is that, as I said earlier, LLM code suggestions, they just guess code. Like they don't have any actual static analysis context here. Then also safety guarantee. So all optimizations are not necessarily the most optimal way to go through it, because there might be any micro optimization or a memory bloat existing. So to solve all these problems, we decided to create a model called CodeForge. Now, this is the architecture. Um, as you can see, the Python code is first inputted. Then we have our AST rule analyzer that basically parses through the code, makes sure that it's syntactically correct, and then detects the rules. And then we have a semantic detector that employs a CodeBot model, which is by Microsoft. And then we have the LLM rewriter. And after the code is outputted, the AST rule analyzer again, it passes through the code to check whether the output code is syntactically correct, and then it goes through the safety guard checks. So we have like 5 safety guard checks, which includes like correctness to check if the code is correct. Then there is a memory bloat. So for example, if the code has optimized, but then there's like more than 50 percentage of usage of memory, it's not necessarily very efficient. So it detects that. Then there's micro optimization. Micro optimization is when, let's say, the code has optimized like less than 5 percentage, but then the uh, the actual like optimization is not that much. Like it's just like the lines have increased at the complexity has increased exponentially, but the optimization is just like a small factor there. Like the speed up is not that much. So that's what a micro optimization is. Then we calculate the confidence score using a proper mathematical confidence scoring system, where we are, instead of using linear scoring that gives hard thresholds, we make sure to include logarithmic, sigmoid, and um, exponential decay, which makes our scoring system much more production ready and reliable than a normal linear scoring system. Now, this is an example of the pipeline flow. First, like you can see on the left side, we have an unoptimized code. The AST basically detects that the range of len is where the unoptimized rule is, like, and then it basically transforms this into a more optimized rule, where we are here using a dictionary for it. Then the semantic code word basically it does a semantic match. So we know that like if two things are very structurally different, it might actually be semantically similar. For example, a for loop and a while loop are very different structurally, but then they're actually similar in functionality in a lot of programs. So that's what CodeBot searches for. Then all these hints are combined together and sent to Gemini as a prompt. And then whatever we get back, we make sure that its safety check is performed on them. So you can see the speed up was 4.7. 3 anti-patterns were formed, and our confidence score is 93. And that means the safety guard outputs a verdict that it's okay and it's safe to apply. There's also reject and review needed as other verdicts, which will give a developer a hint that okay, you need to work on this code more, or do not rely on this optimized code completely. Now, this is what I've already told methodology. There's an AST rule engine, there's a semantic pattern detector. In semantic pattern detector, cosine similarity is computed, and if the similarity is more than 0.75, it groups them into semantically similar. Then the LLM rewriter is also there, which merges the findings from both the tier 1 and tier 2, and it's injected into it. So AIDS module architecture, here we have a rule-based optimizer that consists of all the 12 engineered hard-coded rules that is completely based on the compiler knowledge. And there's a semantic pattern detector. There's the LLM optimizer, and rule transformer works hand in hand with the rule-based optimizer to transform those detected rules. Then the safety guard and the benchmark runner, which basically compares the time. So it compares the runtime of the unoptimized code and the optimized code. So we had tested out 20 programs and we got like all hinted detections were found, all the safety guards were passed. The maximum speed up we achieved was 5.1 and the maximum confidence score we achieved was 93. So then the limitations of this is that first of all we are only working with Python. The scope's just Python, but in future we are planning for multi-language support. Then there's no it's not a sandbox executed. There's obviously an API dependency, but we do have an offline mode which basically goes through those 12 engineered rules that I mentioned earlier. And it's a file based data set, and also the benchmarking scope is also, you know, it's not, it doesn't involve like cross environment validation. So that's it, and I'm done speaking about my paper.
Okay, Shri Kumar sir, you can go ahead with your questions.
Yeah, just a one simple thing, right? So this code force, and what way this provide explainability for its optimization decision? I think you have highlighted the explainability, right?
Oh, for explainability, so if it's an online mode, it basically uses the LLM itself for the explainable. It's an AI explainer. But if it's an offline mode, we've also, instead of giving like vague statements, we've, along with those 12 engineered rules, we've also given an explanation, like depending on what it detects.
Okay. So how does
Yeah.
the developer trust this transformation that is applied to this code?
I'm sorry.
So how does the developer will interpret, right, or trust this transformation that you are applying to this code based on the
So to
optimization?
make to make sure that the code is completely reliable, that's why we do the we make sure that the code that is given from the LLM, it's not directly just like given to the developer. We make sure that the code is completely syntactically correct, and that it is like safe to apply, that it does not go through any micro optimization, or that it's not the same thing as before. And we check if it's like, if there's any like code size has been doubled or something, which is not really necessary, or if the complexity of the code has increased too much, but the optimization is not that much. We go through all these safety checks to make sure that the developer only gets reliable code.
Okay, thank you.
Yeah, thank you, sir.
What key features does Codeforge provide?
The features we have is that it is the goal is simple here. It just transforms unoptimized code to optimized code. But instead of other applications that already exist, like let's say the GitHub's Copilot, what it does, it guesses the code and it basically gives you code alongside. But this model ensures that the code you get is completely validated, it's measured, and it's mathematically validated. Like it's not just given to you, it's made sure that it's actually optimized, and that, you know it's like the most optimal form basically. It's measured, it's completely backed with like proper mathematical scoring system.
Okay, thank you.
Thank you.
Okay, so next up we have Nyuti Bhesania to present her work titled as Predictive Modeling of Mental Health in Engineering and Medical Students Using Machine Learning Techniques. So Nyuti, are you there in the meeting?
Am I audible?
Yes. Are you ready?
Okay. Yes.
Yes, so I'll stop sharing my screen. You can start.
Uh, can you see the screen?
No, yes, yes, yes.
Okay. So, good morning, everyone. I am Niti Pesania, and today I'm presenting a work on predictive model of mental health in engineering and medical student using machine learning techniques. So mental health issue is among the students are increasing rapidly, but many cases got undetected until they become serious. So our problem statement, because the student, especially in engineering and medical field, face high academic pressure, leading to stress, anxiety, and depression. However, traditional methods rely on surveys and in-person delays the intervention. So there is a need to early prediction system. So our objective is to detect the mental health earlier uh, using our machine learning techniques. Uh, we also aim to identify key factors on which is affecting student and enable early detection. To create a scalable, our objective is also to create a scalable and user-friendly system. So we previous works have some gaps and limitations which our work is fulfilling, such as they are not comparing a particular students, like we are comparing engineering and medical students and focusing on them mainly. Some of them has are not doing a feature importance. Some of them are working on a small data set and not using evaluation metrics. So the structure of our work is firstly we take two data set for engineering student data set was taken from the fixed set, and the medical student data set was taken from the Kaggle, and then we did the pre-processing such as data cleaning, balancing, feature extraction, using imputation, encoding the categorical variable, and the normalization. Then we move to the machine learning techniques using model logistic regression, SVM, and random forest XGBoost. And then we do it evolution metrics to see the complete performance of all the models using accuracy, precision, recall, F1 score, and ROC. Here's the details of our data set. The first of all, engineering data set was taken from the Pixar, which contains anxiety, stress, depression of the student. Calculated these types of values, which includes the demographic, academic, and lifestyle features. The key features from that on which the whole data set was relied was the quality, workload, and internet usage of the engineering student. Then the second data set was medical student data set, which was taken from the Kaggle. In this, the medical student uh, analysis and classification data set include this psychological and behavior factors. The most important features on which the mental health of the medical student was rely was stress level, exam pressure, and the social support. And the result show strong performance. Logistic regression performed best for the engineering student with the accuracy of 89 percentage, while the IC boost performed best for the for the medical student with the value of ROC accuracy of 92 percentage. Here the logistic regression achieved performance with the ROC of 0.998, indicating near perfect prediction on the first of the graph. And then the second graph, it was for a medical student data set, XGBoost and ensembled models show strong performance with ROC above 0.90, ensuring reliable classification. So for the applications of this proposed system, this system can be implemented as a web or a mobile application, which can be used by the institutional, educational institutions, healthcare and counseling, digital health platforms. For example, you can see in this graph that the students input these features like demographic, academic stress, lifestyle, and psychological factors and behavior data. Then it will move to our machine learning model. It will clean the data, handle if there is a missing value, encoding, scaling, picture selection. Then it will move to the ML model for the medical student as we have XGBoost, and for the engineering student we have logistic regression. Then it will assume three category. It is low risk, high, medium risk, or high risk. Uh, and then it on the basis of the prediction, the early actions can be taken. As I have already said, it can be used in universities. We can integrate in web application, counseling center, and early intervention. We are also aiming to integrate this using IoT in the watches of the students. So and use SOS if there is a anxiety attack or panic attack on the basis of a BP, which is regulated on the wearable watches, then the SOS should be sent to their closer ones. As you can see that as the future scope is use of large and more diverse data set and integrating in a real-time monitoring system like apps, wearable devices. You can see in the image application of advanced deep learning model we can use if we get a large data set, development of a model and web-based application expansion to other domains beyond the students. Here's the conclusion. To develop a machine learning model for a mental health prediction to identify key factors to provide early detection, stress, anxiety, depression. Thank you for your attention and any question.
Sir, even go ahead.
Hello.
Yeah. So, yeah, I have a quick question on this. Which model you prefer, like, in terms of reliability and accuracy and
Uh,
interpretability?
I think if the data set is complex, then we should go with the XGBoost because it handles very nicely.
Okay.
Yeah.
Okay, thank you. Yeah.
Okay. Yeah, is this application web-based, cloud-based, or standalone application?
Right now, we have just trained the model, but we are in the future we are also thinking to upgrade it to cloud-based so that we can integrate it into watches.
Okay, okay. Thank you. Thank you.
Okay, so next we have Ajidhashini Tulsidas to present her research work titled as Readiness Assessment of Electric Vehicle Driven Green Logistics Practices. So, Ajidhashini, are you there in the meeting?
Yeah, can I share my screen?
Yes. You can share your screen.
Yeah, I'm sharing.
Yeah.
Is it visible?
Yes, it is visible. No, actually, it is still black.
Still
Yeah,
black.
yeah, yes, yes. It is visible now. You can start.
Okay. Shall I start?
Yes, yes, you can go ahead.
Yes. Good morning, everyone. I'm Hajitashini Tulsidas from Coimbatore Amrita School of Business. My research title is Readiness Assessment of Electric Vehicle Driven Green Logistic Practices. So first, I will go for the overview of my research. So this is a follow-up, begin with the context and behind of our study, and I will go through the research gap and objective of these studies and methodology part. And finally, I will make one conceptual framework and the output of the fuzzy readiness index, and I have identified the weaker attributes for the one case study organization. So introduction. So mainly, green logistic practices are focusing on the environmental and technology and organizational challenges. So this is motivate more for the three first, EV, why environmental imperative. So electric vehicles can significantly cut carbon emissions and directly supporting the net zero and supply chain goals, as well as the logistic firms are increasingly expected to meet the second technology advance in the rapidly. And EV and digital telemarketings and the digital battery systems and ERP integrations are maturing the rapidly, and EV digital telematics and operationally the organization remain the major challenges, and these there are a clear structure and systematic readiness is approach is needed. So I use the fuzzy logic methodology. And what are the research gap and study objective of my study is there's a no period study examine the factors like how are the charging infrastructure, what are the financial barriers facing by the some organizations, and what are the holistic view. So there's a no existing model integrated the technological and financial and operational and behavior readiness simultaneously in the similar single framework. And there's a no particular shortage of the quantitative and multi criteria tools for the SME logistics, as well as there's a no developing the comprehensive framework also. So here I have used the fuzzy logic and identify the weakest readiness attributes and the proposing the target strategies. So next, my study objective is developing the readiness assessment framework and identifying the weaker attributes limiting the successful transition towards the EV integrated green logistic operations, and propose targeted strategies and policy recommendation to the EV-driven logistic readiness things. So here, literature review. EV market penetration. So our methodology, so these 6 themes, like one is EV market penetration, last mile EV integration, carbon benefits, and digital technology readiness, and green HRM leadership. So these are the main influencing the factors for the EV readiness things. So first one is EV market penetration. Range and charging availability are cited as the top adoption determinants. For the last mile and deployment, charging delays and grids capacity and remain significant barriers. As well as on environmental benefit, context-based specific logistic planning, it's a critical. And green HRM also research shows leadership and employee engagement are virtual drivers for the that's changing for the local petrol diesel to the EV vehicles, as well as the digital readiness. Teacher highlights telematic on the ERP integrations and the key enablers. And collectively, there's a no single study has brought all these diamonds together into the one holistic readiness model, and that is the gap was addressed. So there's a and a research methodology. Here I'm using the fuzzy logic approach. Our methodology is a majorly 5-step logistic process. So we developed the one comparison the 3-level readiness hierarchy through the literature review and the expert opinions also. And the senior logistic and EV specialists are assigned the importance weight to the each enabler criteria and attributes. And from the each organization, I will take one person who's the expert. So here I will use one case organization from the Tamil Nadu area and other organization from the other states in Tamil Nadu, Kerala, like that. So here 5 operational from the very low to very high our weightages, and from the worst to excellent is our performance rating. So these linguistic ratings were converted into the triangular fuzzy numbers like quality FN's number and aggregate into the single fuzzy readiness index. The key advantage of fuzzy logic is proposed by the study in 1965 is ability to handle the intern ambiguity and the implication in the human judgment. Easily we can understand the methodology. So here I have chart the flow chart of my study, how I identified and how I come to the overall result. Like first I've done a literature review and I have a contact with the expert consultation also. From that I have identified the enablers, criteria, attributes for the EV logistic readiness. Next, I have assigned the importance weightage for the thing and collected the readiness rating, whether worst to excellent. Then I have converted into the triangular fuzzy numbers like ABC. So compute it from the fuzzy performance index and aggregate into the enabler. And finally, I come with the readiness results. And here I use some keywords and code words like for the understanding of the each and everything. For the W means for the ratings and H means for the weightages results. And here readiness capability measurement and each and everything I can show you. So here I have shown like how we are using the important weightage linguistic value. For the higher side, we are using the very low to very high. So very low means here ABC. So very low, low, fairly
Ajitashri,
low,
there's a
medium,
reminder
fairly high,
for
and high,
you.
very high. And for the performance rating, we will use like a worst, very poor, poor, fair, good, very good, and excellent. According to that, the linguistic value will be changed. For the example, for the very low, A could be 0, B is 0.05, C is 0.015. So here my chart, which are my enablers and which are my criteria, which are my attributes. For the example, my first enabler is organizational readiness. So there are sub criteria like leadership, strategic commitment, and government policy structure and organizational capacity development. And from that each criteria, there are 4 to 5 attributes there. For the example, for the leadership strategic commitment, under that, there's senior leadership backing, environmental strategy alignment, and sustainability vision clarity, and change of the management capability, and sustainability championship. And for the governments and policy structure, here there's a formal green logistic policies how we are following, and compliance system inside the companies how they are following it, and the carbon management guidelines are they follow each organization following it or not, and internal sustainability audit system is there, and stakeholder engagement mechanisms. Here I have find out the one framework like for my final target is identifying my readiness index. For that, which is more effectively saying like for the organization readiness and technology readiness and human readiness and policy and environmental alignments and the financial readiness. So here my final results after overall all the attributes and criteria and enablers. My study was my case organization is which is based on the Tamil Nadu and Coimbatore based EV logistic company. I will mention there is an NYX company which is average ready for the EV adoption technology because organizational readiness ranking was 4.27 and technology based they are 4.54 and human capital also they are rightly increasing because they are 3.93 because as per our study, threshold value was 1.02 and they are average ready for the EV transition in their sector. And here I have mentioned final readiness fuzzy enable readiness index for the each fuzzy organizational and technological and human capital. Here I have find out which are the attributes they are more want to focus, like which are the attributes they are lack of the in each of the companies, like changing the management capability is very low. I have identified as which is below a threshold value, and sustainability seminar workshop they have to do more and battery component supply readiness and ERP IT system integration and internal sustainability campaign between the collaborators and the companies and charging infrastructure. So in Tamil Nadu area, they think they want to more implement the charging infrastructure and the maintenance of the EV charging infrastructure also, and the EV maintenance training. The lack of employees doesn't know how to maintain the EV. If there are any failures, how to we can come up with solutions. Then former green logistic policies, are they following? There's some lack of policies, and they want following some kind of government schemes also, but they are not that much of implementation inside the companies. So, and EV operational skills between the high level employees to the low level, like they don't have any kind of some idea of how if they can manage the situations. And recognition reward systems, they won't go with the some things. Here I have mentioned for the week, each and week attributes, what are the suggestions for the futures, and what are the suggestions implement for they can implement for the future movement, which is average ready. So average ready to ready and the highly ready, they can how they can move. So here I have finalized the 12 week attributes for the each and everything. I have mentioned some suggested improvement they can follow for that case organization. So the example for the change of the management capability, I have structured their structure roadmap, then how they can strengthen the leadership
Ajitashini, there
involvement.
is a reminder for you. Please wrap
Yeah,
up in 10 seconds. It's time.
sure. So this is my conclusion of my study. There I have identified the 10 weaker attributes for this my using the case organization. So there's a lack of formalized sustainability policies and training programs, integrated digital system between inside the case organization. There's a culture and behavioral gaps between the reflect the poor score for the sustainable camping and the recognition system. And this is proposed a multi-attribute specific framework for replicable and measurable and evidence-based tool for logistic management and and planners. So my future research is scale for the large firm. This is a very simple and small scale firm. I have done my research. So my next future research is for the large firms like good Air India's like their logistic systems, and I will AI integration for the machine learning for the more identification and the real-time readiness scoring for the from the organization, and policy impact study for the each organization. Thank you.
Yeah, so I request if there are any questions you can ask. Shri?
Yes, good morning.
Good morning, sir.
Yeah, what are the major barriers in EV adoptions in many of the countries?
Sir, because of the costs, financial issues, sir. So they suddenly they want from the petrol diesel to EV, and the infrastructure also. There are some implementing EV adoption vehicles is cost wise is very high.
Okay, and how does EV performance vary under heavy loads?
Yes, sir. So the which I have conducted on the case organization, they don't follow the EV for the long vehicles and long travels. They saying for the infrastructure barriers there. So if there's any issue between the route optimization, we can't that optimize the route. So they're saying we will use only EV for the short and short logistic parts only.
Okay, thank you.
Thank you, sir.
Okay, Shri Kumar sir, do you have any questions?
No much, but the quick question on like there are various technology you just mentioned, right? A lot of cyber attacks has been happened um, for the railway system that has been using CBTC, TCS, SCADA, and all this. So did you find like why they are vulnerable? Like what are the technologies they are lacking for which they are vulnerable to the cyber attacks? Did your paper research that? What are
No,
the technologies? No. Okay. Okay. Thank you.
thank you, sir.
Okay, so we'll move on to the next presentation. Again, we have with us Vishnu Kumar sir, who will be presenting his paper titled as Socioeconomic Drivers of Supplemental Nutrition Assistance Program Participation in US Urban Communities, a machine learning analysis of Baltimore City. So, Vishnu Kumar sir, are you there?
Yes, I'm here. I
Yes,
can.
also I request every participant to please uh, wrap up your presentation within 8 to 9 minutes. It's a humble request to everybody so that the session will close on time. So I'll stop sharing. You can start with the presentation. Yeah.
Okay, so hello again, everybody. So my name is Vishnu Kumar. So for this presentation, I'm going to talk about our research on socio-economic drivers of a supplemental nutrition assistance program, which is also known as SNAP, participation in U.S. Urban communities, a machine learning-based analysis of Baltimore City. So I'm here with my colleague Natalia, and we'll be quickly going over our presentation. So first, introduction. So, at least in the US, the Supplemental Nutrition Assistance Program, which is also known as SNAP, is the largest federal food assistance program. So, it provides support to low income households, helping reduce hunger and improving nutritional outcomes. Now, statistics shows that in 2024, the SNAP served about 40 million people, representing about 12.3% of the population. And as you can see from the figure here, the SNAP participation rate has been going up all the way from 2000 to 2024. And this has been consistently the largest assistance program that exists within the US. Now, people have been researching about SNAP in the past as well. And it has been found that the SNAP participation varies across urban neighborhoods, reflecting some underlying socio-economic disparities that might exist in those regions. Now, in our work, we are just focusing on this Baltimore City. So where the racial segregation, poverty, and unemployment, and of course, housing instability have shaped the disparities in the SNAP participation rate among the people living there. Now, we are seeing that the data-driven approaches that can identify the vulnerable communities and uncover the relationship between the factors affecting SNAP. Now, people have been researching this in the past, and based on our literature review, we found that most of the research is based on a traditional statistical approach only. And it has also been reported that some of these basic statistical linear models have limited accuracy, and they often do not consider the complex interplay between the different contextual factors that drive the SNAP participation rate in an urban setting. Now, in this work, we feel that machine learning would be a great solution to overcome some of these challenges with the traditional approaches. So people have also used machine learning models in the past, and then they focus on general areas like food security, malnutrition, and poverty. So those areas have been researched in the past using machine learning. People have created multiple supervised and unsupervised machine learning techniques to study these topics. However, a gap still remains in applying machine learning to the SNAP participation rate, especially at a neighborhood level. So in this work, we want to investigate how the socioeconomic factors influence SNAP participation in a neighborhood setting. So we are focusing on one city, and then we hope to identify the factors that can affect the SNAP participation in the city of Baltimore. Now, so the research objectives. So we first start with collecting data on various socioeconomic factors within the city. And then our goal is to train a machine learning model to predict the SNAP participation. Now, once we develop the model, then we also use this SHAP value, which is the Shapley Additive Explanation values, to identify the most important features that affect the SNAP participation rate. So the overall goal is that by developing this SHAP-based approach, this is an explainable AI approach, we would like to provide more insights on how the socioeconomic determinants of SNAP participation can help policymakers and other public health practitioners develop a much better sustainable use of the SNAP in the future. Now, moving over to the methodology. So first, the data description. So the slide here shows the data that we used for our model. Now, most of this data was obtained from the Baltimore Neighborhood Indicators Alliance. So that's a local community-based center that's located in Baltimore City that collects data on various socioeconomic features within the city. They have features such as the income, unemployment, poverty, households that have female as the househeads, then households that have no vehicles, the people who cannot afford rent, people who don't have high school education, and then there's another assistance program called TANF, which is Temporary Assistance for Needy Families. So that's another assistance program. And then we also look at the life expectancy, housing vouchers, and school meals that's obtained for each household. Now, the city is divided into 55 community statistical areas. So we collect data for all the 55 statistical communities. So this data is publicly available in the Baltimore Neighborhood Indicator Alliance BNIA website. So that can be downloaded and used for free. So all this data is publicly available and they can be used for free. So in this work, we are looking at about 11 features for the particular city, and that's again used for the modeling process. Now, for the model training, we looked into 3 machine learning models. One is the XGBoost, random forest, and decision trees. So we are using Python software, and then the dependent variable, of course, is the snap participation rate with the 11 socioeconomic features as the input features. And now the testing training is the 80-20 split. And then we benchmark our model using the usual regression metrics, such as the MAE, just a mean absolute error, mean square error, root mean square error, and the coefficient of discrimination, which is the R square value. Now, moving over to the results. So first, we wanted to look how the SNAP participation is distributed across the different neighborhoods within the city. So we've the first observation is to identify the top 5 neighborhoods that had the highest SNAP participation rate. So those neighborhoods are shown in the slide here. So we see that there's a large disparity in SNAP participation rate, with some neighborhoods having a high percentage use, whereas there are some other neighborhoods where the usage is pretty low. Now, we then create the machine learning model to predict the SNAP participation rate. So the slide here shows the results that we obtained from our modeling process. So we find that the DT stands for decision tree, RF is random forest, and XGB is XGBoost. Among the 3 machine learning models that we used in our work, we found that the random forest model exhibited the highest R square value and the least error for MAE, MSE, and RMSE. So that seemed like the better performing model among the 3 options that we picked for our analysis. Now, once the model was created, we wanted to know what are the input features that is driving the SNAP participation rate. So for that particular cause, we use the SHAP, the SHAP, which is Shapley Additive Explanations, that will provide more insights on the impact of each and every input feature on the output. So using the SHAP, we can compute what is known as a feature importance plot. So that is shown here. So essentially, this plot gives us 2 pieces of information. So one is the set of features that significantly affect the output, and that is listed in the top here. So features like the median income, the TNF recipients, the female household, and high school education were the most significant drivers of SNAP participation rate, whereas the features listed in the bottom had less impact on the prediction process. So that is something that we obtained from the SHAP plot that was very insightful. Now, the SHAP plot also gives the direction of the impact. For example, is the impact a positive impact or is it a negative impact? And that can be obtained from the color coding that is shown here. Now, I'm not getting into the details of the color coding because it might take a bit more extra time, and I just have 2 minutes left. So essentially, if a color coding changes from red to blue as you move from left to right, it means that the value moves from a higher to a lower value. And in the next slide, I'll actually show what that means. So our random forest model showed as I said, it showed the best performance. Now, from the SHAP value, we found that the most influential features, which are the features listed in the top, were the median household income, which had a negative impact. And if a feature has a negative impact, then the color changes from red to blue as you move from left to right. Now, the features such as the TNF recipients had a positive impact. So if a feature has a positive impact, then the color changes from blue to red as you move from left to right. So you can see that the first one, it changes from red to blue, which is a negative impact. And if a feature has a positive impact, the color changes from blue to red. So these are the 5 features that we looked into, and the impact for all the different features are shown here. So we have household income negative, TNF recipients positive, female headed household is positive, residents with high school diploma is positive, and expectancy has a negative impact. Now, what is the implication of this? So we find that it reinforces the need of addressing economic inequalities like income education disparities, because they were shown as the most impactful feature that affected the SNAP participation rate. Now, we also found that the neighborhoods that have highest SNAP participation rate may benefit from targeted outreach and coordinated social service approaches to address the socio-economic vulnerabilities that the communities are facing that particular areas. Now, one way to improve this is by providing more access to education and the job opportunities that might help them rely less on all those food assistance program, and then they can overall strengthen their community resilience. So the work has few limitations. So the first one is we actually did at a neighborhood level, but we did not capture individual person by person analysis. So ours is a neighborhood level analysis, and it may not reveal an individual level insights on what drives the SNAP participation rate. Now, again, the SHAP value, which is a Shapley additive values, does not establish any causal relationship. It is just a observed correlations, and that doesn't equate to causation. So I want to conclude by saying that by combining the predictive accuracy with meaningful interpretability using explainable ML approaches such as the SHAP value, we can provide a framework for informing evidence-based interventions. So with that, thank you so much for your attention, and I'm open to any questions that you might have. Thank you.
Ask questions.
Yes, Vishnu, what is the impact of SNAP on poverty levels?
Okay. Let me share my screen again. So in our analysis, we found that the poverty level is somewhere in the middle, which means that it has very less impact when compared to the top 6 or 7 features that is listed here. So which means that a person having more poverty has less, at least from our data that we collected, has less impact when you compare income and the houses that have female households and education level.
Okay. And how does SNAP reduce food insecurity?
So the SNAP is not predicting food insecurity. So it's so SNAP is used to the SHAP. This is SHAP. So SHAP is used to explain how the model made those decisions. So essentially, it says which of the input features control the prediction or how it drove the prediction. Which means the values of median income, these 5 values had the highest impact on the predictions, whereas the things listed in the bottom had no impact on the prediction. Our model just didn't think that these drove any patterns for the predictions.
Okay. Thank you. Thank you, Vishnu.
Thank you.
Yep. Thanks, Vishnu. I don't have much, but Baltimore you refer as the data, right? You have used for your analysis, for your research, right? The SNAP
Yes.
data.
Yes.
So did you consider those irregularities around 30% that's been highlighted this year for Baltimore SNAP data between the federal government and the state? They have identified around 36% of error in SNAP because of the fraud. So have you considered this as a part of your analysis?
So I have not, because that is something. So we just did this work some few months back, and this data was directly obtained from the BNIA.
SNAP, right? Yeah.
Yes.
So there is an error in 36% enrollment data in SNAP for Baltimore itself. Is the highest one in the US.
Okay. Okay.
Yes.
Well, I didn't
So if
consider
you're considering
that
that data from their website, from Fed website, probably
yeah,
that'll
okay.
calibrate. Yeah, that's what I say. That's okay.
Okay. Thank you for that information.
Yeah.
Okay, so our next presenter is Hector Rafael Morano, who's going to present their paper titled as Study LLMs to Extract Coordinates from 2D Counter Engineering Drawings. Hector, sir, are you there?
Okay. Yes, sure.
Yes, you can share. Also, to give you the information that he is also a session chair for other sessions. So please share your screen. We'll stop sharing the screen. Yeah, you can start.
Okay. So, hello everyone. I'm Hector Morano. I work for Tecnológico de Monterrey, campus state of Mexico. The title of this presentation is Study LLMs to Extract Coordinates from 2D Contoured Engineering Drawings. So this is the agenda I will follow. First, I will give a brief introduction. Then I will mention the objectives of this work. Subsequently, I will describe the methodology that we use. And finally, I will share the conclusions and future work. So engineering drawings are standard graphical representations of parts or assemblies that allows users to interpret their dimensions or geometry. Evaluating the possibility of an LLM interpreting these engineering drawings could be enable automation of the task and reduce processing time. So the objectives of this work were, the first one was to evaluate whether an LLM can interpret an engineering drawing. And the second one was to identify whether they used the standards for interpretation. And the last one was to determine if users as students can employ LLMs as a guide to interpret drawings. So the LLM's use was ChatGPT based on GPT 5.2 in its free version. The computers employed were laptops with an i7 processor at 2.5 gigahertz and 32 gigabytes of RAM. The CAD software application employed to generate the engineering drawings was Fusion 360, which offers free academic licenses from students, and the files are stored in the cloud, allowing them to be downloaded and modified from any computer. So the methodology consisted of 4 steps, as shown in this figure. So initially, LLM was asked about engineering drawings. This was done through questionings, and subsequently the LLM was asked what information could be extracted from the drawings. To further introduce it to drawing interpretation, various images of engineering drawings were provided, and some observations on the notations were made to facilitate understanding. Based on the LLM's responses, feedback was provided and some additional drawings were provided for interpretation. And finally, the information extracted from the drawings, which consisted of the coordinates of the start and end points of the different entities, was analyzed. To understand how the LLM contextualize an engineering drawings and what could help it extract the start and end coordinates of the geometry entities that compose it, the LLM was asked to generate an image of an engineering drawing. So the result is shown in this figure number 2. To demonstrate to LLM how to create and interpret a drawing, an image of a drawing representing the same part was provided. This drawing is shown in figure 3. It is the same part but contains fewer geometry entities. So using the prompt shown in this figure, in figure 4, the details were described. An element was asked if it agreed with the coordinates and the number of geometry entities. So the LLM was asked about any ambiguities it identifies. Subsequently, the LLM was provided with another image of a drawing with a close contour, but this time separated from the origin, which we can see in this figure. The element was asked to extract the coordinates of the entities that form the contour, as well as to mention any possible ambiguities. Based on figure 2, the LLM state that it assumed units in millimeters and one origin at 0, 0 at the bottom left and a close counterclockwise contour. To understand the reference points for the geometry entities, the LLM was asked to generate a table listing their coordinates. It can be observed that line 2 doesn't actually exist. It is a reference combining the absolute and relative coordinates of the dashed lines. The same applies to ARC2. Its endpoints are not at the position LLM mentioned. So the following table shows the coordinates extracted by the LLM from the drawing in figure 5. Incorrect coordinates are highlighted in yellow, primarily on the x-axis, where the errors occur. It loses the reference to the origin in the lower left corner. So the LLM fails to account for the initial 5 millimeters on the x-axis. Even the coordinates of the arc centers have error on the x-axis. So here we have the conclusions. So LLM is familiar with the engineering drawing the standards and recognizes the importance of documented information. When an LLM interprets an engineering drawing, it doesn't rely solely on the standard that define them. Instead, it identifies the dimensions and links them to a reference system. So the LLM verified these dimensions mathematically, and for anything to explicit state, inferred the expected results. Anyone requesting an LLM to interpret an engineering drawing must be familiar with the relevant standard to correct potential interpretation errors. As future work, we distinguish the following tasks. The first ones, it is recommended that LLMs undergo training before being asked to interpret engineering drawing. This ensures they understand the reference system and units required for analyzing the dimension for different geometry. And it is also recommended that engineering drawings be explicitly designed for LLMs to facilitate their interpretation. This could be achieved, for example, by using colors to identify a geometry entity, including a symbol to represent the origin of the reference system, and possible incorporating a grid in the background of the drawing to serve as a dimensional reference. So thank you very much. If there are some questions, I'll be glad to answer them.
Yes, good morning, sir.
Good morning.
Yeah, how this LLM is integrated into CAD software?
Well, we are trying to develop this type of research to automate the information that we can get from the different drawings, engineering drawings. So
Okay.
right now, we don't have any development to incorporate this proposal to the different CAD software applications. So this is the first step. We are analyzing how this type of LLMs can react or respond when we ask for some information.
Okay, and how does this LLM is different from traditional NLP models?
This is a basic or a common LLM, ChatGPT. So we wanted to know if we can use it to get the information of the engineering drawings. But we found that we need to change some engineering drawings using colors to facilitate the LLM to interpret this information. So this LLM is common and is basic for this kind of task.
Thank you, sir.
You're
Shri
very
Kumar sir,
welcome.
you have any questions? Okay, I think he doesn't have any questions, so we'll move forward.
Okay, thank you.
Yeah, thank you so much, sir. So next we have D. Shweta, who will be presenting her work titled as Synthesis and Characterization of TiO2 nanoparticles for the detection of hazardous gases using AI/ML. So Shweta, are you there in the meeting? No, she is not present in the meeting. So there are two more papers left. Okay. We have Ashwini Zadgaonkar ma'am to present her research titled as a decentralized architecture for secure data sharing using blockchain. Ashwini ma'am, are you there in the meeting? Yes, I can see her in the meeting.
Yes, ma'am, I am there in the meeting.
Yes, you can. Are you ready with the presentation?
Yes, ma'am. Yes, ma'am.
Yes, you can start. I'll
Yes.
stop sharing.
Is my screen visible, ma'am?
I'll stop sharing it one second.
Can I
Yes,
start, ma'am?
yes, it is
Yeah.
visible. You
So
can
the
start.
title of my work is Decentralized Secure Data Sharing Using Blockchain and Smart Contracts. So the list of author is being displayed. Myself, Ashwini Zadgaonkar, along with my other research mate. So in this work, we are trying to find out or propose a hybrid blockchain architecture for confident, temper-resistant, and auditable data sharing across distributed system. So the main focus of our research is on the decentralized architecture which is proposed for the data sharing, smart contract access controls, off-chain hybrid storage, and cryptographic integrity that need to be added to our work. So,
Sorry to interrupt you, Ashwini ma'am. You have
yes.
to wrap up this presentation in 8 to 9 minutes.
Yes, ma'am. Yes, ma'am. Yes,
Yes.
sir. Yeah. So there is a need of a secure data sharing pertaining to the increased amount of data in the different domains. So like if we are considering about the explosion of the data centric application like healthcare, IoT, and smart cities, so that is contributing to that. Then there are certain core security requirements like privacy, integrity, and trust for all the application. And there are certain limitations of the centralized solution which are being identified in the past. So that is the single point of failure, cyber attacks, vulnerability, lack of transparency, and dependency on the third party intermediaries. So to overcome this problem or to address this problem, our research objective was to propose a decentralized blockchain-based framework that eliminates trust dependencies while ensuring confidentiality, integrity, and fine-grained access control. So these are the problems which are being visualized with the centralized data sharing system. That is the single point of failure, which is the main problem which is being encountered with the centralized system. Cyber attack vulnerability, lack of transparency, and blind trust in the intermediary. So to these address these shortcomings, the applicability of the centralized system in high sensitivity domains such as healthcare, finance, and inter-organizational data structuring is highly sensitive or it is highly risky. So we are trying to provide the approach which will try to address this shortcoming. So we have identified the blockchain as a solution to address this shortcoming. So as we are aware, the core blockchain properties is the decentralization, where it is providing the distributed validation by network participant to eliminate the need for centrally trusted authority. It provides the immutability, that is the transaction returned to the blockchain form the irrevocable ledger which will be there forever. Then we have the smart contracts as the core component of the blockchain, which is a self-executing program which automatically enforce access control rules and data usage policies. And then we have the transparent auditing facility available where all the data transaction and access events are logged permanently, which enables file-grained auditability and accountability. So these are the blockchain-based data sharing benefits: trust enhancement, non-repudiation, fine-grained access control, and scalability via off-chain storage. Now, we will like to focus on our proposed hybrid system architecture, which is divided into two layers. We have a data layer and we have a control layer. So our control layer is composed of the blockchain, which is taking care of user registration, access control, and audit logs. And then we have a data layer, which is off-chain storage, which is storing the encrypted object references and the hash values, which are being created for the data set. So this architecture decouple the main focus, the main distinguishing feature of this proposed approach is this architecture decouple the data management from access control. That is, the blockchain control layer handles the trust, policy enforcement, and auditability, whereas the off-chain data layer that is responsible for holding or storing the large data objects, enabling both high security and practical scalability. So the design goal for our proposed hybrid system architecture is to prevent unauthorized access to sensitive data, tamper-resistant cryptographic integrity checks, and flexible role-based and attribute-based access control. The key properties of this proposed system is transparency and traceability for all data access, scalability through off-chain data storage, and no trusted intermediary it is required over here. So this is the diagram of our research paper, which is talking about the different modules. That is our user module and blockchain module. So in the initialization part, the resource owner is going to execute the smart contract, which is available into the blockchain layer. Then these are the different modules which are the part of our system. So we have the initialization module, which is required for registration. Then we have the access control module, and then we have the monitoring or inspection module. Now, I would like to explain the end-to-end data sharing workflow, which is there in our system. So when the user sends the data access request, then it has to be sent to the blockchain network, which is going to execute the smart contract to provide the access to the data. Then it goes for the data classification, and then the desired data by the user will be retrieved. So in this case, the data request is being sent, access permission is given, it is going to retrieve the data by verifying the hashes which are available with the off-chain layer. The trustless workflow over here ensures that the raw data is never going to touch the blockchain layer, and every access event, whether it is being approved by the system or denied, it is being permanently logged into the system. Integrity is being verified end to end by comparing retrieved data against the on-chain cryptographic hash. So this is what is the security measure which is being incorporated into this system. So basically we have these four modules. So we have a data registration where the hash plus metadata anchored on-chain by the smart contract. So this is the raw data which is being stored on the off-chain. Then you have an access request module. Users submit the requester ID and data ID to the smart contract for the policy evaluation. Policy enforcement, that is based on two types of techniques, that is the role-based and attribute-based technique, and time-based condition, they are evaluated to grant the user request. And the last one is the integrity verification, where the retrieved data hash compared against the on-chain record to confirm the authenticity of the data which is being required by the user or retrieved by the user. Now, our smart contract-based access control model, it is supporting role-based access control and attribute-based access control, as well as the time-based. There are some time-based restriction also. So the smart contract capabilities, it is a decentralized, tamper-resistant policy enforcement, dynamic permission grant, revoke, and update is possible over here. Immutable audit trail of all access requests are possible. Deterministic authorization without intermediary is available in the through smart contract. Access event login for accountability and revocation mechanism immediately to block the access. So all approvals and denials are logged permanently in the blockchain ledger, enabling full visibility and post-incident forensic analysis. So in the role-based access control model, the permissions are issued according to the predefined user role, like the administrator, healthcare provider, researcher, or enterprise user. In the attribute-based access control, access decision based on the user attribute, that is organization, department, clearance levels, or the contextual condition. And the policies can also be enforced with the temporal constraint, restricting the access to specific validity windows only. So these are the three types of access control which are being incorporated in the smart contracts.
There is a quick reminder, you have to wrap up in 1 to
Yes,
2
ma'am.
minutes.
I'll skip some PPTs and I will directly jump to the performance and evaluation result.
Yeah,
So for
sure.
the performance and evaluation result, we are using this 4 parameters, that is the transaction latency, access response time, computational cost, and scalability. So these are the 4 parameters on base of which we are trying to simulate the environment, which will give you some kind of evaluation result over here. And these are the 2 graphs that is being generated from our research work. So the first graph is showing the transaction latency versus the number of users. So if we increase the number of users for the experimentation purpose, what effect it is having on the transaction latency. So these are showing the values where our proposed system is showing the result, and then we have compared it with the centralized system or full on-chain blockchain. So basically our proposed approach, we have compared with remaining 2 types of system, that is the fully centralized system as well as full on-chain blockchain, where we are trying to propose the hybrid approach, which is a combination of these 2. This is the second graph that we have generated, which is denoting the storage cost comparison with respect to the 3 approaches. So this is what is the storage capacity requirement of our proposed system. This is one for the full on-chain system, and this is for the centralized system. Now, the key results and the discussion that would I would like to conclude my presentation is, through our proposed approach, we have observed low transaction latency, because storing only the hashes and metadata on chain keeps the transaction size small, reducing the execution time significantly compared to fully on-chain alternative or the approach. Stable access response, off-chain storage handles large data transfer without burdening the blockchain network, maintaining responsive user experience at a scalable level. Minimum storage overhead, only cryptographic hashes, metadata, and access control records are kept on-chain. Large data object stored off-chain to minimize the blockchain bloat significantly. High scalability is also confirmed through our proposed approach, because scalability test confirm stable performance under increasing access request volume, validating the hybrid decentralized architecture for production scale. So in the conclusion, I would like to say that the proposed decentralized blockchain-based architecture resolved inherent weakness of centralized data sharing, including single points of failure, lack of transparency, and unauthorized access, through the combination of blockchain, smart contracts, off-chain hybrid storage, thereby delivering secure, scalable, and auditable data sharing without trusted third parties. So thank you very much. I hope I have completed my presentation in time.
Yes, good morning, ma'am.
Good morning, sir.
So how does this blockchain ensure data security?
Sir, the first objective of the research work is we want to maintain that transaction latency, and second was we have to provide the data security. So over here, we are only storing the hashes onto the blockchain, and the actual value is stored off-chain. So in that case, by comparing with the hash value, we are trying to provide the security to the data. So hashing technique is to be implemented over here.
And what are the common blockchain attacks? Blockchain attacks.
Sorry, sir. Like I'm not recollecting at the moment the type of blockchain attacks.
Okay, thank you, ma'am. Thank you.
Yeah, thank you, sir.
Okay, thank you, ma'am, for presenting.
Thank you, ma'am.
So, Jeba Priya, are you there in the meeting? Let me check. Yeah, she's there. Jeba Priya, can you hear me? Are you there in the meeting? Okay, I think we should move on to the last presentation of today. D. Shweta, are you there?
Yes, ma'am.
Yes, so
Yeah.
we have D. Shweta who's going to present her paper titled as Synthesis and Characterization of
Of
TiO2 nanoparticles for detection of hazardous gases using AIML. So, are you ready with the presentation?
yes, ma'am. My student is ready with the presentation because my throat is not well, so that's why. Okay, he also joined. He will continue with the presentation,
Okay,
ma'am.
okay. You
Okay,
can share
this is
the
our
screen.
comment. Yes, ma'am. He will start. Okay, ma'am.
Yeah.
Thank you. Madan, continue.
Ashwini ma'am, can you stop sharing your screen, please? Yeah.
Hello, ma'am. Is my screen visible?
Yes, it is visible. You can start. You have to wrap it up in 8 to 9 minutes.
Yeah, sure. Good morning, all. Our presentation is on synthesis and characterization of TiO2 nanoparticles for the detection of hazardous gases using AIML. Uh, I'll give a brief about what we are going to talk about. This is the contents. This is the roadmap of our presentation, where we are going to talk about the objective, the introduction, the process which we followed, the methodology which we used, and ending with conclusion and future scope. Uh, Objectives, we had three major objectives in our study. First was to give a comparative analysis of the machine learning
Madan,
model.
screen not visible.
Ashwini ma'am, can you please stop sharing your screen from your end? Yeah, I'll stop it. Yeah, you can share.
Is it visible now?
Yeah, yeah.
Yes. You can start
Our
from the
study has
top.
three main objectives. First is to conduct a comparative analysis of machine learning models. The models which we used in our study were XGBoost, SVM, and MLP models. Second was to identify which model is more accurate and more efficient, and third was to find concentration of the gases which we want to detect. So why we want to do this? The so hazardous gases is a critical challenge in industrial safety, environmental safety, and even in healthcare. So semiconductor metal oxides sensors are used here. Why we have to use semiconductor metal oxides here is it is uh, it is low cost. It provides the best and high sensitivity, and it also gives compact form, um, where the traditional detection methods still suffer from slower response time as compared to these semiconductor metal oxides, and have limited sensitivity as well. And integrating this with AML will help in better detection accuracy, and improving our efficiency as well. So this is our process flow. So how we started this project. The data which we used for this project was from a data set from UCI repository, and we first pre-processed the data set which we collected. Then we use the data set. Using the data set, we trained three models, mainly XGBoost, SVM, and MLP, and we evaluated these models based on mean absolute error and R square, and we plotted accuracy and sensitivity plots and compared these three models' performance. So this is the first model I'm going to talk about, which is SVM model. Uh, SVM is support vector machines. Um, the principle of this model is to find the best plane to adjust all the data points within this plane. Uh, the strengths for SVM is its robustness to outliers and its ability to handle non-linearity, and some other strengths are uh, it works well for small and medium sized data sets and can handle high dimensional data sets efficiently. And this is the result which we got for SVM. We got an accuracy of 83.3% when comparing different gases and their concentrations. And the next type of model which we studied was about multi-layer perceptron model. Basically, a multi-layer perceptron model is a combination of three different layers. It has an input layer, hidden layer, and an output layer. The input layer is basically the data which we feed, that is from all the sensor signals. Hidden layers perform the extraction, and output layer gives the gas concentration and gas type. And we train this using back propagation and with Adam optimizer, which will help to minimize mean square error. So this is the result for MLP model, which gave an accuracy of 94.4%, which was the highest among all the three models which we studied, and which also talks about neural capabilities of ML. But computation costs of MLP is higher as compared to the other two models, and uh, and we have to be careful in the hyperparameter tuning as well, and as well as it is much more computationally demanding as well. And the other model is XGBoost. XGBoost is extreme gradient boosting. It Basically, this model builds decision trees, and based on the errors from previous decision trees, it corrects those errors to build newer decision trees. And XGBoost gave a model accuracy of 83.3%. That is like classifying about 8 of 10 cases. And while MLP had an accuracy of 94%, uh, this was more consistent and while handling multiple gases and concentrations at the same time.
Just a quick
So,
reminder, you have to finish it in next 1 minute.
yeah, sure. I'll maybe jump to the results. So this is the confusion matrix where we have a linear diagonal which shows its accuracy, uh, and these are all the different type of gases which we had in our data set. They are acetone, ethanol, ethyl acetate, and so on. So this is the mean absolute error in this model. So I would like to conclude that all three machine learning models which we used successfully classified hazardous gases with their classifications. But among the three, XGBoost was the most dependable because it was able to give strong accuracy as well as it was able to handle multiple gases with different combinations of concentrations at the same time. And a future scope for our project, uh, we see uh, we see this project can be deployed in factories, in smart cities for continuous environmental monitoring. This can be used in disaster response, like detecting gas leaks in environments. This goes very well with mining operations as well. We would be able prevent accidents happening in the mining industry, um, in healthcare industry as well, where we can monitor anesthetics and so on. Thank you.
Anybody has any questions?
Yes, what is the main objective of your research?
Sir, the main objective was like to compare different AI models in detecting hazardous gases.
Okay.
Sri
Okay,
Kumar,
thank you.
sir, do you have any questions?
No, thanks.
Okay. So, Jeba Priya, are you there in the meeting? One last call for you. Okay, so I think
Yes, ma'am.
that's
I am available.
okay, but now you cannot present your paper. You just have to summarize what all is your research about in quick 2 to 3 minutes.
Yes, yes. Shall I share my screen?
Yes, you have, but remember you have to wrap up in 2 to 3 minutes. Just summarize everything.
Yes. Yes, my screen is visible.
Yes, it is visible.
Very good morning to one and all present here. Am I audible, ma'am?
Yes.
My topic, that is my research article topic is boundary-driven lightweight segmentation framework for robot image enhancement in CCTV surveillance. And then my introduction to main thing, that is a CCTV system generate massive surveillance data, and then the manual monitoring is inefficient and then error prone. And then the main objective, that is main objective of this work is image enhancement during that segmentation process. Here the segmentation is the foundation for the crime analysis. The problem statement, there are a few problems will be observed when you're capturing on CCTV. When you're capturing a data from a CCTV, we have a lot of images will be captured, and then it will be degraded by using degraded by low illumination and then motion blur occasion images. So it will be that is in existing model there is a loss of boundary precision when you are doing with that segmentation process. So some small objects or small things are missed, and then that will be lead to our incorrect crime analysis. So we will focus to that segmentation process, and then we will focus that how the boundary will be predicted, and then how will you identify, and then how will you capture the small objects by using the segmentation process. And then there are a few gaps, the research gaps will be observed. And this model, it focuses on a global context, and then the boundary informations are treated as a secondary. That is the boundary data, that is the outline of that image, or a few the outline objects will be that is of, some smaller objects or smaller things that are observed in that boundary or outline, that will be treated as a secondary. So that is it will be poor performance in the crowded scenes as well as the overlapping when you're going with the overlapping objects. So for that we will go on to that boundary driven segmentation. In this research paper, in this article, I
Sorry
will
to interrupt you, Priya. I request you to please jump to the methodology and the conclusion
that
quickly. I request you to please jump to the methodology and the
yes,
conclusion quickly.
yes, okay. And then the objective, that is finding that uh, that is a boundary segmentation, that is boundary, and then enhance that image, enhance that images. And then in this proposed system, I use the lightweight model, that is edge prime segment network model, for doing the boundary segmentation approach, and then extract the counters before that region segmentation. And then this model is a lightweight model that will be used in the deep learning concept. And then in a lightweight architecture, we will use the 2.18 million parameters only, and then improve the small object detection, and then get a better bound preservation, and then that will be used for a CCTV application, real-time CCTV applications. The main methodology is it consists of the four modules. In this model, that is the edge-like crime set network. It consists of the four modules, and then that is a pipelining. That is first we are capturing the images from that CCTV, and then we are doing the four stages. First one is the first module. We are doing the encoding of that regions. And then next second module, that is boundary extraction enhancement model. We are doing the refinement of a boundary extraction. That is, we have captured the boundary extraction. And then in the third module, boundary guided refinement, region refinement, we are doing the refinement process. And then finally, we will do the decoding for the image enhancement. And then finally, we will get that enhanced image for that will be used for a crime analysis. This is the overall model of this, that is edge line, crime set network. And then each and every model will do that for instance, giving the raw data, and then next one we are down there, that is extracting the boundary edges, and then they're doing the refinement process, and then we will decode that, and during the decoding process the masking will be taken place. There is a separation of the foreground images as well as the background images, and then finally we will get the image enhancement that will be useful for a crime analysis. And then these are the steps that is observed. And then in this boundary image, that is the boundary strategy, that is extracting the features, and then using of lightweight CNN model, and then introduce the complexity. And then in second module, that is the refinement model, that is it will predict the boundary confident map, and then enhance the important edges, and then suppress those noises, and then focus on a crime relevant context. And then in the refinement and then the decoding process, it prevent the region leakage, that is boundary leakage, and then maintain the spatial consistency, and then preserve the small objects, and then produce the final segmentation. And then here we are using the UCF crime data set for this in this paper for extracting the images. It consists of 1,900 real-time videos of 128 hours, and then it will consist of different anomaly categories. For example, abuse and harassment in phishing. Likewise, we have different types of categories are available with that anomaly images as well as videos, and then we will extract the images using the videos by using the method H-line, crime segment, networking method. And then finally we will get the enhance the images. And then we are using that, this is a sample, a result and discussion, sample images Here I am given that two types of categories. One is taken from the W's images, and the second one is RS images. First one is a original frame, and then second one is a deep blurring. Second stage, that is doing that after completing the pre-processing work. Next, move on to the segmentation. In the segmentation process, we do that all the four module steps, and then finally we will get that refined enhancement, that is image enhancement, and then that will be that will given that boundary images, that is it will reduce the leakage as well as the boundary prediction, as well as we will get the final, that is small object images of a small object in accuracy. Again, we are using that few parameters that is I use for this analysis. That is one is the IOE, that is intersection over union, and then dice coefficient, and then boundary IOE, and then F1 square for doing that analysis. After doing that, after this like experiment with that network model, and then we will attain the 95.52 I believe, and then 95.37 dies, and then 95.60 F1 square. This is a comparative baseline with that related works, and then this we have compared with that lightweight models, SN, and then unit, and then segment, and all these are comes under a lightweight deep learning model. We compared with this all this model, and then edge-like crime set model is efficient, and then we will get the accuracy on the basis of IOE. I will get 95.52, and then dials IOE 95.37, and then F1 square 95.6, and then the baseline, that is IOU, that is we will get to 94. And then ablation staging for segmentation, we'll compare with that few more lightweight models. For that, we are using the following parameters. We will find that accuracy improvement, and then include accuracy, precision, recall, F1 square, and then map, and then flow ITC. So you will get a better result, a better accuracy with a low complexity, and then a high difference. And then some findings will be observed, that is an image and enhancement improve the recognition accuracy, even though it will give that improvement. That is when you are using with that heavyweight lightweight model, it will be somewhat give the limitations, and then essential environment issues are remain a bottleneck problem, and then edge computing is emerging as a game changer for a real-time time analysis. And then conclusion, finally, we will observe that as the edge-like crime set model, we will get the better accuracy with this following analysis. I will 95.52 score, and then 95 parameters, and then prompts. And then in future, when you are incorporating, we will extend this method by incorporating temporal coherence across the frame by introducing the recurrent attention mechanism, as well as we will optimize with the spatial temporal options for getting an image enhancement system. Thank you.
Okay, so anybody is willing to ask any questions? Okay, so Nitin sir, yes.
Yeah, ma'am,
Yes.
what are the outcomes of your research work?
I will get a better accuracy of image enhancement, that is images, and then complexity will be reduced when compared with that heavyweight model. That lightweight model, we will be work with the limited parameters. Minimum number of parameters will be used for doing this analysis. So it will reduce the complexities, as well as we will get that high speed inference speed, and then we can also get more that is small objects, like this. All the small types of objects will be absolutely that is we find that we can get that absolute small objects, and then boundary leakages will be reduced.
Okay, thank you, ma'am. Thank you.
Yes.
Okay,
Thank you.
Shri Kumar sir, do you have any
No,
questions?
thank you.
Okay,
Thanks.
so here we come to the end of the session. So I sincerely thank all the authors for their excellent presentations and their valuable contributions, and all participants for being an important part of this international conference. So I truly hope this session was insightful, engaging, and inspiring for everyone. So on behalf of the entire team, we thank you for your continued support, not just for this 11th edition but for all the previous 10 editions of ICTIS. We look forward to welcoming you again in the 12th version in 2027. All presenters will receive their digital certificates via email within 2 working days. The publication will be live within 7 to 8 months, so we kindly request your cooperation with the ICTCS 26 team. Also, I would like to extend my sincere thanks to our session chairs, Dr. Nitin Dhawas sir and Dr. Shri Kumar sir, for expertly chairing this session. So, this certificate is a small token of appreciation on behalf of Team ICTCS and Global Knowledge Research Foundation and partners. So, thank you all once again for your valuable presence. So, before we officially wrap up this session, let's capture this moment. I request everybody to please turn on their cameras so that I can click a quick snapshot of the conference. Wait 1 second. I request everybody to please turn on their cameras. Shweta, Ashwini ma'am, Priyanka, Ajit Hashini. Okay.
There is a small issue with my camera. Okay,
Yeah, that's fine.
just a minute.
Yeah. So thank you so much everyone for being present here. Stay safe. Take care everybody. Thank you so much
Thank
Thank you,
everyone.
you.
ma'am.
Thank you to the session chairs.
Thank you.
Thank you.
Thank you. Thank you.
Thank you.